teacher, yeah, right.
My teacher wasn't the greatest teacher.
I'm kidding, all right? Don't go yeah, right, all right? Don't do that. Okay, and rational functions, basically you have a polynomial over another polynomial. I think you remember you studied this, you have asymptotes. I always cannot pronounce this word very well. Asymptotes. Okay. Okay. I think we need to leave that word. All right. Okay. The next you learn exponentials. Did you? Logarithm. Yes.
Mm-hmm.
Then what? Trig. Inverse trig. Right. Those are the functions you learn. But in applications, we need more than this. So we learn how to build the functions from the functions we already know. What do? If you are given a function f and g, I can build new functions from this. I can add them. You just add the value and x together. That's your new function value. All right? You can multiply them. You can subtract them. Of course, you can divide them. Right? These are the normal way to build functions. But there is one more way, which I'm not going to say much about here, all right? There is one more way which is very important to build new functions. What do you think, Adam?
You can compose them together.
You can compose them together. That would be called composite functions. All right? Composite function. That means f of gx. That's our notation. What does this mean? That means f of gx, really. Literally, you are taking functions of functions. And actually, this is what I tell you to do yesterday. If you look at this. F of gx, the order is important here. F of gx, this is f of gx. There are different ways you can do this. You could do this in, okay, f of gx. When I evaluate this function at gx, that's 3gx plus 1. Am I right? Then I throw in the formula for gx, that's 3 multiplied 1 over x squared plus 1 plus 1. Yes? But g of fx, I will do it in another way. It's still g of fx, that's by definition. And this should be g of 3x plus 1. I throw in the f formula first. Then I'm evaluating the function g at this. This actually is 1 over 3x plus 1 squared plus 1. Some of you give me this as 9x squared plus 1. That's wrong. All right? We cannot make such mistakes in calculus. All right? So you can simplify this, multiply it out, but it's not necessary. That's how you build new functions through computation. Of course, there is a problem about the domain. The domain, you really need to be all the x such that gx is defined, and also the gx, the value for g, should be in the domain of f. Right? I'm not going to go into that. Okay? I'm not going to go into that. Just be careful, the domain might be restricted. All right? The next thing, of course, you can talk about inverse. When a function has an inverse?
When it has 1-to-1 ratio, or the 1-to-1, like for every x value, there is one y value.
I thought every function is like that. Every function for every x value, there is only one value corresponding to it. Right?
There can be two y values for one x value if the horizontal line test shows that there's 2 points, isn't there?
No, I think you get the right idea, but I think there could be 2 x values corresponding to the same y.
That's what it is.
Right?
Yeah.
Okay. Everybody, when the function is 1-to-1, that means for each x, there is a different y corresponding to the x. Then I can make the function go backward. Right? That we define the inverse function. Okay? I give you another problem here. Find the inverse function of f. this is the straight line. The inverse function is this. It passes horizontal line test, right? How do you find the inverse function? You set y equal to 3x plus 1. Interchange x and y, switch x and y, then solve for what? For y. All right? That's the procedure. I'm not going to spend too much time reviewing this, the inverse function property, but when we come to this, I will review it for you again. Like the relation between graphs and the domain, range, relation. All right? I will do that later on. This problem is a simple evaluation. If fx equal to this, I want f2x. Some of you did wrong. This is kind of alarming. Why? Because the function, when fx equal to this f of 2x, all you have to do is replace what? X by what? 2x. Officially speaking, f is a rule, is a relation which tells you how to get y. You can put the x at any value. You just read. I could let you calculate f of dog. Does that make sense? Yes. It's 2 dog squared plus the minus 3 dog. Whatever dog is, this relation is this. You just replace by the quantity here. Right? So we need to know that. We need to know that. Everybody, does this make sense? Okay, I don't think I need to tell you about these problems, right? I did read what you wrote down, okay? But anyway, this is, let me check my notes here. Actually, there is another type of function, it's a piecewisely defined function, everybody. Are you familiar with that? Yeah. Okay. Basically, you have a function defined by different formulas on different intervals, right? And in that case, you have to be careful where your x is, use the correct formula to evaluate the function. So again, I'm not going to go there again on this, but anyway, let me check. I think that's the end of my review, basically. I know it's rough, it's quick, but we really cannot afford too much time. Everybody, if you feel too rusty on this stuff, test 0 will tell you that, you know, I think you might want to quickly review certain things. Or as we move along, when you need it, go back to review. All right? So let me start on chapter 1. Is there any question before I move on? Yeah?
Are we going to have any of this test your quiz on the review?
I don't intend to, am I? You mean if I tell you no, you don't have to review it?
No.
If you tell me that, yes, it will be. I think we are on schedule to have a quiz on Friday. So I really think the domain is a very important concept. Okay? So I intend to include the review material, what I reviewed for you on the quiz. Of course, when I tell you something is on the quiz, do not mean I will put it on. That's not a contract between you and me. I must put it on. The quiz is about 10 minutes, so I cannot put on everything. But for you, you do have to review it. All right? And chapter 1, I want to talk about limits and continuity. Limits and continuity. Now, your book has an introduction section, which I'm not going to do that for time's sake. All right, I'm not going to do the first introduction section. Basically, what I want to do is briefly describe to you what calculus is and why we need to study this topic. Because you don't know the topic yet. Supposedly, you don't know the topic yet. So it doesn't make sense for me to go too deep into the introduction. So what I want to tell you, what calculus is about? Do anybody know? We actually, in calculus, we will study functions. Where do your function come from? It might come from various applications. Physics, economics. It comes from everywhere. Now, what do you want? What are you going to study about functions? For example, you can study where the function is increasing, where the function is decreasing, where the function reaches a maximum, where the function reaches a minimum. Right? How fast your function is increasing. Right? So that's a question. Now, in order to study this, we need the concept of rate of change. That's basically derivatives. Some of you, many of you are not the first time you heard some calculus concept. In order to define derivative correctly, we really need the concept of limit. So that's what we start with. All right? Limit is the foundation of calculus. It's a tough topic. It's a tough topic. Okay? But we need it. So here, let's start 1.2 in your book. That's the concept of limit. Now, what I'm going to do is try to give you some examples. And through these examples, I'm going to abstract out the concept of limit, give you the definition and the notation. All right? Give you the definition and the notation. And I just feel I hate to leave these seats empty. Next time, sitting in the back, do you mind sitting to the front a little bit? We don't have a seating chart. That seat is not reserved for you here. Anybody can come to the front, all right? But anyway, I just see. I mean, I know I move around, but so far, 17 years, I never kick anybody in class. So, no fear, all right? Okay, the concept of limit. I want to give you some examples. Through these examples, I want you to think about the problem. So we want to abstract out the limit definition. Let's start with an example. So I want to consider fx equal to x squared minus 4, x minus 2. I don't want you to think this example is so easy, I already see what is going on. I want you to think about it. Because our purpose is to generalize this situation. I want to consider the behavior of y equal to fx near x equals 2. Okay, there is a reason why we do that. Everybody, first let's find the domain. There is a denominator. I need to make sure the denominator is not what? 0. That's easy. X equal to 2. Make the denominator equal to 0. So the domain is all the x do not equal to what? 2. Right? X do not equal to 2. So what we are interested in, fx is not defined at 2, but I'm interested in what happened at 2. Is your function behave wildly, or your function kind of well behave? What happened? So let's study this. At this moment, I will stay with kind of numerical evidence. Okay? So if you have your calculator handy, you could take it out, help me calculate the function value. That would be great. All right? So what I would like to do, give you a little table value. Actually, your calculators have a much better tool. Maybe I should put it down. Maybe have you used the least function in your calculator? Let me just show you. I think everybody can see it, right? Okay. I guess you need to turn it on. And then what you are going to do is put in the function. Let's see, I want to put in the function which is x squared. I'm really bad in this. You have to watch out. I might punch in something wrong, all right? Minus 4, am I right? Parentheses is important here. Divide by what? X minus 2, that's my function, right? Did I put in the function correctly? Yes? Then I want to use the table value. I'm interested in the value near 2, right? So I'm going to use the table set. Do you see that? Table set. So I wanted to start near 2. Let's say I want to start from 1.5. Then I wanted to, the increase